Resistors are found in most electrical circuits, and their primary function is to limit the flow of electrical current, or in other words, to resist current flow. The resistance of a resistor is defined by Ohm's law. Here, resistance is calculated by dividing the voltage, also called the potential difference, by the current flowing in the circuit. This equation can be rearranged so that if you know two of the values, you can use them to calculate the third. The unit used in this calculation are ohms for resistance, volts for voltage, and amps for current. You will use this application to explore the properties of resistors and how they can affect the flow of electrical current in different electrical circuits. You will examine how resistors in series, such as the example shown here, behave differently to resistors in parallel. Most wires found in an electrical circuit contribute very little to the resistance in the circuit. However, some wires, such as those made from alloys of nickel and chromium, have high resistive properties. You will use this application to explore how the length and diameter of a nichrome wire determines its resistivity. To explore how resistors function, singly and in series, select the first option and enter the experiment. Electrical circuits need a voltage source, and you have the choice of using either a 9-volt battery or a 1.5-volt battery. For the purposes of this video, we will select the 9-volt battery. There is also a selection of different resistors. The resistance of each is indicated by its 4-color band code, but you can also see the resistance by hovering around a given resistor. There are 10 resistors with a known resistance. Though please be aware that no two resistors of a given rating will necessarily be identical. This is because the resistors are manufactured to conform to a certain tolerance. These are gold band resistors, which means the stated resistance can vary by plus or minus 5%. There are also 4 resistors of unknown resistance. However, don't worry because you can use this application and Ohm's law to determine their resistance. On the left, we have an experimental setup, which is similar to the one you would find in a physical laboratory. And to the right of this, we have the same setup, but now presented in a simpler form, making it easier for you to interact with this application. The circuit has a battery, a switch, a voltmeter to measure voltage, an ammeter to measure current, and finally 2 slots where the resistors will be inserted. To measure the resistance of a single resistor, select the resistor and place it into one of the slots. To complete the circuit so that the current can flow, you will also have to insert a wire into the second slot. Once your components are in place, switch on the circuit. Make sure you record your resistor selection, the voltage and current readings in your laboratory notebook. To explore how 2 resistors in series alter the properties of a circuit, insert a resistor into each slot and switch on the circuit. You have the option of using 2 resistors of the same rating or using resistors with different ratings. To return to the application homepage, click on the blue icon at the top left corner of your screen. The middle option allows you to explore how resistors in parallel affect the flow of current. The setup is very similar to the resistor in series experiment, but as you can see, the resistors are now arranged in parallel. Simply insert your chosen resistors and switch on the circuit. Make sure you record your chosen resistors, voltage, and current readings in your laboratory notebook. The third option allows you to examine the properties of 3 nichrome wires with different diameters. The setup is also similar to the previous experiment in that there is a voltage source. Here it is fixed at 9 volts, a voltmeter, and an ammeter. Here you insert your chosen wire into the circuit, so it is aligned with a meter ruler, and complete the circuit by clamping the crocodile clip onto the nichrome wire. There's a zoom-in view of the ruler to make it easier for you to record your selected length. Use the switch to activate the circuit and record the voltage and current readings together with the length and wire you have chosen in your laboratory notebook. You can select a different length by moving the crocodile clip along the wire. However, beware, if the length selected is too short, the current flowing through it will cause it to heat up. To change the wire, just insert the new wire into position. Once you have collected your data observation, your teacher will take you through the next steps.